Welcome to episode 64 of 100 Days of Data. I'm Jonas, an AI professor here to explore the foundations of data in AI with you.
And I, Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
The language of databases. That's what SQL is all about. It's how we talk to data.
Right, Jonas. SQL might sound technical, but it's really just a way to ask questions and get answers from databases, like having a conversation with your data.
Let's start by breaking down what SQL actually is. SQL stands for Structured Query Language. It's the standard language used to communicate with relational databases. Think of it as the language that lets you ask very specific questions about your data.
And by relational databases, you mean the kind that organize data into tables like spreadsheets with rows and columns, right?
Exactly. Each table holds data about one kind of thing: customers, products, sales, and so on. The genius of SQL is in how it allows us to access, manage, and manipulate that information, no matter how big or complex the database is.
I've seen companies use SQL daily, from retail chains checking inventory levels to banks running fraud detection reports. It's everywhere.
Historically, SQL was developed in the 1970s by IBM researchers. Back then, databases were becoming too large and complex to handle with file storage alone. SQL introduced a declarative approach. You tell the system what you want, not how to get it. This was revolutionary.
And that shift makes it accessible to non-programmers, right? Instead of writing complicated code, you just write queries that say, for example, give me all the customers who bought more than $1,000 last month.
Precisely. That declarative style is a big reason why SQL remains the dominant language for databases today.
Let's talk about queries since you mentioned them. In simple terms, these are the questions you ask your database using SQL.
Yes, queries are the core. They're essentially statements composed of clauses like select, from, where, order by, and so on.
Select is the part that decides what columns or fields you want to see, right?
Correct. Select picks the data. From tells the system where to look, the table name. Where filters the data by certain conditions.
So if I want to find all customers from New York who made purchases last month, my query would select customer names from the sales table where the location is New York and purchase date is last month.
Exactly like that. It's simple syntax, but powerful.
Now, in practice, the power of SQL shines with joins. Those are ways to combine data from multiple tables based on related columns.
Right. A join lets you answer complex questions, for example, linking customer info with their orders or products with suppliers.
I've helped automotive clients merge their vehicle maintenance records with customer purchase histories using joins to personalize offers and schedule service reminders.
That's a great example. Instead of isolated pockets of data, SQL lets you bring everything together seamlessly. Another key concept is that SQL databases follow a schema, an organized structure defining tables, columns, data types, and relationships.
Yeah, I've noticed when companies don't define schemas well, their data gets messy fast. It makes querying inaccurate or slow.
Precisely. A good schema is like a well-organized filing cabinet. It speeds up data retrieval and ensures consistency.
But I've also seen newer approaches where some businesses use flexible schemas or even schema-less databases like NoSQL, especially when dealing with varied or rapidly changing data.
True, but for structured, relational data, which is still the backbone of many enterprises, SQL databases remain crucial.
Let me share a story from healthcare. A hospital I worked with used SQL to analyze patient records and identify risk factors for readmission. By querying data across treatment tables, lab results, and demographics, they improved care plans.
That's a perfect illustration. SQL enables integrating diverse data to generate insights that impact decisions directly.
And it's not just healthcare. In finance, banks use SQL queries to look for suspicious transaction patterns and report compliance metrics rapidly.
Now, while SQL is powerful, it's also very precise. Small errors in queries, like a missing where clause or a wrong join type, can lead to incorrect results or very slow execution.
I've seen teams struggle when complex joins balloon query times to minutes instead of seconds, delaying business decisions.
That's where query optimization and indexing come in. Databases use indexes, kind of like book indexes, to quickly locate data without scanning whole tables.
And good database architects design those indexes based on common queries, right? So the most business-critical questions get answered quickly.
Also, something I often emphasize is SQL's role beyond asking questions. It's used to update data, insert to add new rows, update to modify existing ones, and delete when you need to remove data.
Those data manipulation commands make SQL not just a read-only tool, but a full language for maintaining and evolving your data store.
Exactly. When retailers update stock counts in real time or when financial systems reconcile accounts nightly, SQL is behind the scenes. For listeners wanting to become AI literate, understanding SQL is foundational. It's where data lives and how you get to it.
And from the practical side, whether you want to ask your data simple questions or build dashboards that inform executives, knowing a bit of SQL will empower better conversations with your tech teams.
Before we wrap up, Amy, anything you want to add about the evolving landscape of SQL and databases?
Sure. These days, traditional SQL databases are combining with cloud platforms and big data tools. We see managed services like Amazon RDS or Azure SQL making it easier for companies to scale and focus on insights instead of infrastructure.
And tools like SQL extensions now support querying semi-structured data like JSON, blurring lines between relational and NoSQL worlds.
Right, making SQL more flexible while keeping its familiar query language.
To sum up, SQL is the language that unlocks the vast world of data stored in relational databases. It's how we select, filter, combine, and manipulate data in ways that power business intelligence and AI.
And from a practical view, whether you're in retail, healthcare, or finance, SQL skills translate to clearer insights, faster decisions, and stronger partnerships between business and tech teams.
Today's key takeaway: understanding SQL prepares you to communicate effectively about how data is stored and retrieved, an essential skill for any AI-literate professional.
My takeaway: don't be intimidated by SQL. It's just a way to ask your data the right questions, and those answers can transform your business.
Next time, we'll explore two of the most popular data visualization tools, Power BI and Tableau, and how they turn data into decision-making dashboards.
If you're enjoying this, please like or rate us 5 stars in your podcast app. We love hearing your questions and ideas, so drop us comments anytime. You might hear your story featured in a future episode. Until tomorrow, stay curious, stay data-driven.